Which of the following series will converge? 3 to the n over n factorial over n to the fifth, or n over that. Okay. Okay. So let's start with the first one. This one will converge. And the way I kind of remember these things is there's kind of a hierarchy where n factorial kind of dominate everything. And then exponential kind of come below that. So just from an intuitive point of view, you look at this and you're like, okay, we have a factorial on the bottom. That's going to go towards the big infinity. That's going to converge. A slightly more formal, though not really formal way of doing it is like, well, let's just say n equals 6. So you have 3 times 3 times 3 times 3. That's 4. That's 5. That's 6. 6 times 5 times 4 times 3 times 2 times 1. And you look at this and you're like, okay, so those will cancel. These two will be less, these two will be bigger, but these 3 will be bigger. And then as this goes off towards infinity, it's kind of clear that the bottom is going to really dominate. And so you can kind of look at this and visually think that, okay, this factorial is really going to get huge, especially compared to just these 3, using these 3s. So you have 3, 7, 3, 8, etc., forever. And that's kind of like, oh, it seems reasonable that the factorial, little exclamation point thing, will dominate and will cause the series to converge to a value. A more formal way of kind of getting the right feels for this, and it might bother you that like, well, you're not being very formal, you're kind of very off the cuff here. That's true, I am. This is really for an AP test, and so when you're looking at AP tests, you really do kind of have to be off the cuff because you're given like maybe 2 minutes to solve this problem, and you're supposed to prove that, well, you're supposed to find out if 3 series converge or diverge, and you can take up whole, 8.5 by 11 pieces of paper proving these converge or diverge. So you really don't have time for a formal proof. It's more like, yes, no. And demonstrating a wide swath of very shallow, thin knowledge of calculus. This isn't a profound situation. Okay. The correct way would probably be the ratio test. Limit natural law, limit as n approaches infinity of an plus 1 over an. And then you're like, well, is this less than 1, equal to 1, greater than 1? And this one is converges. This one is don't know. And this one is diverges. So, which kind of makes sense. If every term is bigger than the last one, then yes, it's probably going to diverge. Will it always diverge? Interesting. I don't think so. Maybe. Yes. Probably. Okay. So anyway, when we do this, we do something like 3 to the n plus 1 over n plus 1 factorial times, and then we'd have n factorial over 3 to the n. As n approaches infinity, this is 3n times 3. We just take out one of the take out the n factorial, 3 to the n. Get my cancellation color. Ooh, that's a little too harsh. Green. No, I had to start with green. Blue. I use like the same 6 colors. You're right, I should use gray. Gray is an underused color. So that will go away, that will go away, that will go away, that will go away. We're left with 3 over n plus 1. N goes to infinity, so you're 1 over infinity, which is less than 1. Therefore, converges. Very much so. So, which of the following series converge? That one will definitely converge. So, and I would recommend using less of a formal development than that, but your general thought process should be, oh, factorial, that's going to dominate. And then if you have to be more formal, ratio test. Okay. Going, because this is the similar. I think you can still use the ratio test for this one. Yeah, I think there's a different test you'd use for this. But from an intuitive point of view, you'd think that, all right, n times n times n times n times n over n plus 1, n plus 2, n plus 3, all to n plus 4, n plus 5, dot, 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 dot. So we're up to limit as n approaches infinity. And I have these upside down, so flip them. But the idea here is you can kind of sort of cancel. I know, infinity plus 1 and infinity about the same. So you get these all to cancel, and then you're still left with a whole bunch of infinities on this side, or n's. And so the idea is this factorial is going to dominate over the end of the fifth, because you only have 5 of them. While in factorial, sure, you have a lot of small numbers involved, but when you get to infinity, you have an infinite number of those. So that makes sense, that would be dominant. Dominant. Yep. I would think so. Okay. So yes, this one diverges. And the quick way to think that is factorial on top diverges. And when you have a factorial on the bottom, that's when you have to start thinking. Okay. Then the third one, we're going to rewrite this. We're going to factor out an n. Okay, the top part's easy to factor an n out of. But factor an n out. The first part, we have 1 plus 1 over n times 1 plus 2 over n times 1 plus 3 over n. And we'll factor out 3 n's. And then we're left with blue. So as n goes to infinity, these go away. And we're left with this is kind of sort of like n over n cubed. It's actually less than, because even though these go away, they'll still add something. So for this, we'd actually, I think, use the comparison test. We'd be like, well, it's almost the same, but it's smaller. So if we can show that this converges, then that has to converge as well. Which is 1 over n squared, which we know that 1 over n squared converges. 1 over n does not converge, but 1 over anything greater than, so like 1 plus 1 or bigger, or 2, will converge. So 1 over n squared series will converge. And you can do that through the integral test. Basically find the area under the curve. You find out that it's finite. Finite area under the curve means convergence. So right here, 1 and 3 only. And that's not too bad. We can do those. Pretty straightforward. Convergence and divergence.